Okay, so the next trend that we want to discuss is called Ionic Radius. So Ionic Radius, the trend here really asks the question, which is larger? We'll say X or its ion. Okay, so whatever the element might be or its ionic form. So if I ask you which is larger, sodium or its ion, the first thing you have to be able to tell me is what is the ionic form of sodium. Okay, the ionic form of sodium is +1. So if you don't know the charge pattern, you can't even begin to deal with ionic radius trends. So let's learn the rule, then we'll learn the explanation. So cations are, so the way I'll write this is cations are either smaller or larger, and anions are either smaller or larger than their neutral atom. So this only corresponds to that specific element. So all we're doing here is comparing one single atom to its ionic form. Okay, so cations are smaller than their, we'll say, neutral form. So that means sodium +1 is smaller than sodium, for example. Okay, so we'll say anions, which have a negative charge, are larger than their neutral form. Okay. So now let's talk about why this trend holds. So let's look at lithium. So the electron configuration for lithium is 1s2, 2s1. So I chose a small atom here because it's easier to see. So let's go ahead and this isn't a great representation because this isn't actually 100% accurate, but it's good for visualization here. Let's draw the Bohr model and draw in the electrons. There are 2 electrons in the first energy level and 1 in the third energy level. So when lithium forms an ion, we know it forms a +1 ion. So it loses that electron. So the ionic form of lithium looks like this. Okay. So hopefully it's easy to see here why the cations are smaller than the neutral atoms, because typically when a cation is formed, you lose a whole energy level or a whole sublevel. So that's a fairly major jump, and that should be a fairly easy explanation for you. So then let's look at an anion. So I have fluorine. So let's say write the configuration 1s2, 2s2, 2p5. Okay. So I could draw that out, but it's a little more difficult to see here. Let's just write the, Now let's write the electron configuration for fluorine with a -1 charge, which is the ionic form of fluorine. 1s2, 2s2, 2p6. Okay? So I look at the outermost sublevel. Okay? So in this case, the 2p sublevel has 5 electrons. In this case, the 2p sublevel has 6 electrons. What do you think takes up more space? 6 electrons or 5 electrons? Yeah, 6 electrons, because electrons have a negative charge and they repel each other. Okay, so the more electrons you pack in a sublevel, the more that sublevel expands, because you can't pack a bunch of electrons really tightly together because the negative charges repel each other. Okay, so those are the explanations, and you should be able to explain that. But this is a simple enough trend. You should automatically know if you have a cation, which one's going to be larger. If you have an anion, which one's going to be larger there. This is by far the simplest of the periodic trends that we'll discuss.